Here is the fifth and final day in exponential functions, looking at interest, simple interest, and compound interest. First off, think about what is interest. And if you guys are going to go to college, which all of you are, you're going to pay a lot of money in interest because most of us don't have the amount of money to be able to afford to go to college. So we have to borrow it from a bank or from a student loan provider, and they like to charge interest. That's how they make their money. So in some cases, banks pay you money. Okay, so interest works both ways. Actually, some cases banks pay you money, so you that's like an investment here. But most of the time, typically the way we see interest is that you have to pay back the bank, and that is when you borrow the money. Right? That's typically the way that we see interest. That's how they make their money. So in history, banks have calculated interest at the end of each year on the original amount, either borrowed or invested. So typically, however much you take out, they'll charge interest on that, and that's called simple interest. So let's take a look at example one. Kyra's been babysitting since sixth grade. She has saved $1,000, and she wants to open an account at the bank where she earns a simple interest rate of 10%. If she does not add any money to this account, how much money will Kyra have after 1 year? How about after 2 years? And how about after 5 years? Okay, so this is super important, guys. Not just for math, this is important for life. You need to know what these three things mean. Your principal balance, that is how much you start off with, how much you take out in the first place. Okay, so she has saved $1,000. That is her principal amount. This is her P. All right. Her principal amount is $1,000. So that's what we're going to put right here. And her interest rate. It's a simple interest rate of 10%, which of course we always write as a decimal. Anytime we have a percent, we're going to write that as a decimal. And what is 10% as a decimal? Well, that's just 0.10. These x's here means that we're multiplying everything across. Times x. And then it wants to know, how much money will Kyra have after 1 year? Well, this is year one, and t is going to be 1 in this case. If we do this math out, which you should have your calculators out ready to do, the interest that she earns is $100. Right? But let's not forget. So she started with 1,000 and she's earning 10%. So after year one, she's earned an additional $100. But we can't forget about the $1,000 she already has in her account. So we need to add that back. So her total new balance is $1,100. Okay? Now, principal for year two. Again, principal's not going to change. It's your original amount, and we're still at 1,000. Her interest rate is not going to change either. It's still 0.10. But now we're on year two, so it's been 2 years. So if we multiply all this across, we would get $200. So she would have earned $200 in 2 years, which means, adding back our principal, she would have a total now of $1,200. And for year 5, I'm sure you guys could figure this out. The principal is still going to be the same, of 1,000, multiplying by the interest rate of 0.10. And now it's been 5 years. So multiply all three of these together, and you would get $500. Adding it back to your principal, And altogether, you would have $1,500. Okay? And the principal, guys, write this down underneath. Anytime we're working with principal in different numbers of years, principal is always the same number. All right, 1,000, 1,000, 1,000. Now, do we already know a formula for simple interest? You definitely do. You actually learned this in middle school. You learned interest in middle school. And what is that formula? Simple interest. See if you can remember it as I'm pulling up the pen. It was, where is it? I of t, where I stands for interest, t stands for time, equals p r t. When I was younger, I always remembered this as iParty, which sounds like iCarly, which is a show that was on when I was a kid. I don't know, just how I remembered it. iParty, iCarly, something like that. I don't know. However you guys remember it. I equals PRT, where I is the interest earned or owed after T number of years. P is the principal amount, the original amount that's borrowed or invested, and then R is your interest rate. So example 2. Raul needs $200 to start a snow cone stand for this hot summer. So he's going to need $200. That's going to be his original investment or original amount borrowed. So he borrows this money. So right here, this is going to be our P, our principal. And it looks like, all right, that works. He borrows the money from a bank that charges 4% simple interest a year. 4% simple interest. Okay, let's redo that. So 4% simple interest. How much will he owe if he waits 1 year to pay back the loan? What if he waits 2 years? What if he waits 3 years? So we actually have everything we need in order to solve this question. One second, guys. Okay. So, again, we're going to do I equals I of t equals PRT. That's our formula. And we know P is 200. Right? That's going to be 200. Our rate, 4%. Well, how do we write that as a decimal? It's going to be 0.04. And then we have 3 different things it wants us to find. After 1 year, after 2 years, and after 3 years. So let's do that here. Let's do I of 1. So after 1 year, it's going to be 200 times 0.04 times 1. So again, once we substitute this in, once we put this in the calculator, all this is finding us is how much interest has been made. So if we put this in the calculator, we would get 8, which is $8, which means that after 1 year, he's going to owe an additional $8. So we have to add that back to his principal of 200. So after 1 year, he would now owe the bank $208. What about I of 2? I of 2 is going to be 200 times 0.04 times 2. There we would get $16. So after 2 years, again, you have to add it back to the principal, his original amount. So after 2 years, he would owe $216. What about after 3 years? It's going to be 200 times 0.04 times 3. That's going to give you 24, but you got to add it back to the principal of 200. So after 3 years, he would now owe $224. So these are your answers here, your totals. Okay. Oh, we don't want that. Okay. Exercise 3. Tammy has $500 in her savings account. Okay, so what do you guys think that is? That's going to be your principal. $500 in her savings account. The bank is offering a simple interest rate of 7.2%. She wants to earn $300 in interest. So this is a little bit different. Look, we have P, we have R here, and it's saying that she wants to earn $300 in interest, so it's giving us I in this case. And it's telling us how long does she have to leave her money in the account. So how long does her money have to stay in the account for? Typically we know it's I of T equals PRT. This time it's giving us I is 300, and it wants us to find how many years, or how long does it take. It wants us to find T. P is 500. R is 7.2%, which as a decimal, 0.072. And then we gotta find T. So this is a simple equation. You guys should definitely know how to do this. Using the calculator, multiply this out. You get 36T on this side. Still have 300 on this side. Divide by 36 on both sides. So T would equal 8.3 repeating, which means it would take over 8 years, right? If she wants to earn $300 in interest. That's how long it would take. Okay. Back page. Now in the 1600s, banks realized there was another way to compute interest and make even more money. Of course they have. Why wouldn't they want to take our money? Shocking. They called this interest compound interest, which is basically the same thing with just a little twist at the end. So to compute compound interest, banks now calculate the interest for the first period, but then they add it onto the principal and then calculate the interest on your new total. So they're getting even more money from you, right? So for simple interest, they would just keep taking the interest from your original principal. And now for compound interest, they're going to take the interest from your higher principal, your higher total, each year that goes on. And what does that mean? Let's take a look at exercise 4. So Jack has $500 to invest. The bank is offering him an interest rate of 6% compounded annually. Gotta be sure we know what we're working with. Compounded annually, that means it's a compound interest rate. How much money will Jack have after 1 year, 2 years, 3 years, or 5 years, and 10 years? So he's starting with $500, right? That's his balance he's going to start with. Let's use blue. So he's starting with $500 as his balance. His rate is 6%, 0.06. So in interest, he is getting $30. But we also have to account for his previous balance. In other words, his principal of $500 to get his actual new balance, which would be $530. So he now owes an additional $30 to the bank after 1 year. So here is the one difference between compound interest and simple interest. Again, the bank came up with this because they want more of your money, which shouldn't shock any of you. $530. This now comes down to your balance over here. And think about why they would do that. Why would they take your new balance, which has more money in it, and multiply it by the same interest rate? because now I'm going to have 530 here times the same interest rate of 0.06. Is that going to be more or less than $30? Well, if we put in the calculator, we would get $31.80, which is more money in the bank's pocket. Because now, if we add to our previous balance our initial principal of 500, now they're going to have, whoops, I meant to put 530 here. Sorry, guys. That should be 530 right here. So if we're adding to 530 here, 530 plus 3180, that's going to give you $561.80. And then your balance now over here is going to be 561.80 times 0.06. That's going to be $33.71. Look at that. It keeps increasing your interest rate. So you're going to add that to your 561.80. So now your new balance is $595.51. So $595.51 in 3 years. And this is a really good interest rate. This really has not increased that much money. Right? So the one difference from compound to simple interest, this number is changing. And this way, this table here, this is what I call the long way. I don't know how much time I just spent on it. Feels like way too long. But this is the long way. There is a shorter way to do this. But let's see this first. What would we have to do to figure out the balance after 5 or 10 years? What would I have to do to figure out that balance? Well, what we have to do is we have to find the interest and balance for every year beforehand. Right? Because whatever the principal is, that has to be the new principal for year 2. Whatever your new balance is, that has to be the new principal for year 3, and so on and so forth. We can't skip any years. So this is why I said this is the long way. But, of course, as mathematicians, they always find a way to make life short and sweet for us so we don't have to always go the long way about things. So compound interest. The formula is as follows. A of t equals P times 1 plus R to the t. And that kind of looks familiar to me. P times 1 plus R to the t. Hopefully it looks familiar to you too, because it's honestly the same as y equals ab to the x. Right? P is your principal, your initial amount, same as A. B, it's saying 1 plus R. B could either be 1 plus R or 1 minus R. And then T is time. Exercise 5. Sarah had invested $800 in a savings account. Okay. $800 in a savings account. That is my principal. Now, the savings account is paying her 4.2% interest compounded. Keyword, compounded annually. How much money was in the account after 4 years if she left the money untouched? So this keyword, compounded, that tells me which interest formula to use. Am I going to use compound or am I going to use simple? Well, I'm definitely going to use A of t equals P times 1 plus R to the t. So I'm going to be using this formula here. Let's fill in what we know. We're looking for after 4 years, how much money is going to be in the account. So we're looking for when t is 4. Well, I know my principal is 800. 4.2 as a decimal is 0.042, so I'm doing 1 plus 0.042 raised to the 4th power. Calculator will do this for us. It will come out to $943.11. Okay. Let's do exercise 6, and then I'll leave exercise 7 for you guys to do. All right, exercise 6. If Bailey invested money 4 years ago, okay, let's think about what it's telling us. Bailey invested money 4 years ago with an annual interest rate of 3.275%, compounded annually. And now it's valued at $11,260. How much did she initially invest? Let's break down each piece. What information is it giving us? Well, if she invested money 4 years ago, that's my T, right? With an annual interest rate of 3.275, well, we know we can write that as a decimal of 0.03275. Compounded tells me what formula I'm using. And now it's valued at $11,260. So that's my value now. That's like my A of T. This piece here. How much money did she initially invest? P. I don't know P. So let's substitute in everything we know. We know A is going to be 11,260 equals. What's it going to equal? P times 1 plus R to the T power. Well, we don't know what P is, so that's going to stay P. 1 plus 0.03275. And we know T is 4 years, so raised to the 4th power. So let's simplify this down again. We're going to have 11,260 here times P. Simplifying inside, that would be 1.03275 raised to the 4th power. Let's simplify that. That's going to be, actually, yeah, no, we got to raise it to the 4th power. So it's going to be 11,260 equals P times, this is a long number, 1.137577 031. So how would I get P by itself? If it's being multiplied, I gotta divide both sides by this whole number. Right, by 1.137577, yada yada yada. And same thing on this side. That cancels out. And we would find P to be equal to $9,898.23. So that's how much money she initially started with. Okay. Do number 7 on your own, and that's the end of day